we have what we call the Carl Pearson's, like the one they want us to use, the Carl Pearson's model. The Carl Pearson's model. And then number two, we have the rank, into bracket here, Spearman model. So we start with the first one, which is the Carl Pearson's model. The Carl Pearson's model. So Carl Pearson's model is used to ascertain the strength, between two quantitative variables. Between two quantitative variables. Remember when you introduced this subject called the quantitative analysis, you said that the quantitative variables are those variables that can take up a numerical value. Those variables that for you to be able to ascertain their value, you could either count. Like you want to know the number of students we have, we'll count. So number of students automatically becomes, or rather belongs to quantitative what here? Variables. So you could either count them or measure them. Count or measure. If, for example, I want to know how heavy I am weighing, what I need to do is to come and, of course, get a weighing scale. Weigh myself. So when you want to get the numerical strength between two variables that are quantitative, like now here we have years of experience. Years, of course, you count number of years. So these are quantitative variables. And the sales is money, you count. So then these are quantitative variables, and the very best thing for you to do if you want to see how closely those variables are is to measure their strength, the bond between them, using Carl Pearson's model. Ladies and gentlemen, Carl Pearson's model borrows heavily from the formula of B. Every time, whenever they tell me, ladies and gentlemen, to write the Carl Pearson's equation, I'll always be forced to remember the formula of B. Once you give me the formula of B, then I will be able to give you the formula of Carl Pearson's R. Anytime they tell me to give them the Carl Pearson's R, first of all, I'll be forced to remember the formula of B. And to get B, we normally talk of N, summations of X, Y, minus summations of X, summations of Y, all over N, summations of X squared, bracket, summation of X done what here? Squared, like that. Formula for getting B. And out of this, I will be able to write down the formula of getting R. The formula of getting R, where R is the correlation coefficient. This R is the correlation coefficient. And for us to get this R, ladies and gentlemen, I've told you will borrow most of the things from here. So you're saying it will be N, summations of XY, minus summation of X, summation of Y, all over N summation of X squared, minus open bracket, summation of X done what here? Squared, like that. Now listen and listen to me. This is now where we bring the modification. You see, this is correlation between X and Y. So in the denominator, you must introduce the Y variable. In the denominator, you must introduce the Y variable, which will follow this format. So here we'll talk of N, summation of Y squared. I'm following the same format. Minus summation of instead of X, I'll talk of summation of Y. Of course, in this case here, this has to be done what here? Square. So if that is the case, then what you need to do, come and put square roots. You can either say to have one, but I prefer both to be under individual what here? Square roots, like that. Allow me to write this formula in a better way. Let me write this formula in a better way. In a way that you'll be able to understand once and for all, ladies and gentlemen. Once and for all, ladies and gentlemen, what we have here. What we have here. So what we have, ladies and gentlemen, here is this. They want us to write the Carl Pearson's equation. For us to have the Carl Pearson's equation, we know that Carl Pearson's has a relationship with B, the gradient of regression. And to get B, of course, every student is happy with the formula. It is n summations of xy minus summation of x, summation of y, all over n summations of x squared, summation of x done what here? Squared, like that. That is a formula for getting B. Once you give me that formula, then I will be able to remember the formula of R very fast. Ladies and gentlemen, the formula of R as per Carl Pearson should be the same thing here. N summations of xy minus summation of x, summation of y, all over n summation of x squared, bracket here, summation of x done what here? Squared. But because this is correlation, core means that we've got two aspects. Whenever we talk of like, there is something shared. When we talk of, for example, co-director, co-author, co-wife, so something shared. So the same case here, because of correlation, we are looking at how X relates with what here? Y. So it means what you need to do, come and put this in brackets like that, open another bracket, come and feature in here the variable Y. So variable Y, what are we going to talk about here, my great friends? It will be n summations of y squared, because I'm following this, minus, open a small bracket here for summation of y instead of x squared. From there, put brackets like that. And then never forget, ladies and gentlemen, that unlike the correlation, or rather unlike the B, for R, we always have square roots there. Two of them, square roots, two of them. So the only thing that you need to do, ladies and gentlemen, for you to be able to complete this particular concept is for you to come here and give us a column of y squared. Give us a column of y squared. Unfortunately, your calculator memory has not forgotten. I would want someone to come and give me the y. We need y squared for us to be able to get correlation. We need y squared. So say shift sum bullet. So that bullet like that until I see sum of y squared, number 1 equals. I want to see what my students are able to get for y squared. I want to see what my students are able to get for y squared. Can somebody help us out? Can someone help us out? Y squared, what are we able to get? 8? 845, 800. Now, let me give you something that destroyed most of my students in this particular exam. Most of my students in this particular exam, they never chopped the 3 zeros. So every time they were writing like 180,000, just try squaring, 180,000 squared. So when they did 180,000 squared to get these, they were getting funny figures. They were getting 3.24 times 10 raised to positive 10. Just imagine that number. Most of them forgot the cardinal rule of this regression correlation. But whenever you have your figures here big in many zeros, chop them, and learn as much as possible to use what here? A calculator. Because the moment I have just like, after chopping this, the moment I have this as 180, if I have to use even the manual way, I'll come on top of 180, then I square like that, which will end up giving me 32,400. So I'll not be having all these hassles like that. I'll not be having all that hassle like that. So ladies and gentlemen, come back here. Let us try to substitute, my friends. Our R here will be equal to n. I know n. The number of points are how many? They were 10. Number of points were 10. Times summation of xy, you guys gave me a figure. Summation of xy was 2110. 2110. Minus summation of x. Unfortunately, I deleted mine. I deleted my summation of x. Yeah, I can see from somewhere 66. times the summation of y, which happens to be 24 what here? 24, 20. And then everything divided by root of n again, 10. Summations of x squared. This is my x squares. So the summation is 514. So 514 minus sum of x alone. Sum of x in brackets here, sum of x. Sum of x is 66. This has to be squared. And then we have square root. Square root, we have n. N happens to be 10. 10 times summation of y squared. Summation of y squared is 845, 800 minus summation of y alone. In the brackets, you see body mass. They want us to put summation of y. Summation of y, ladies and gentlemen, is summation of y is 24. Summation of y is 24. Summation of y is 24, 20, but we do what here, somebody will square like that. Now you have to move very slowly and give us the numerator first. Please give us the numerator value. Give us the numerator value. Our R will be equal to, I don't even want to rely on my calculator. I want someone to give me the numerator value. So 10 times 20, 110 minus 66 times 24, 20. What figure are they able to get the numerator? 41? 41, 380. That's confirmed. 41, 380. From there come to these square roots. We call them sides. So we have 10 times 514 minus 66 squared. What figure am I able to get here? 784. And then we have the other one. The other one will be 10 times 84, 5800 minus 24, 20 squared, which gives me quite a big figure, 2601. Is there anybody who is getting this kind of a figure? They haven't given us. Let us give them time. Let's give them time. Let's give them time. Let's give them time. 26,01600, isn't it? Now from there, what I will do, I'll come and use my experience of working with brackets. So I'll talk of 41, 380 divided by open brackets. Open brackets for the denominator. Denominator, what do we have here? The first one is square root of 784 times another square root 260, 1600. You close the bracket like that. You should be able to get R of 0.916, 0.916. Let's confirm that figure. Or 0.92, even 0.93, I still give you a mark. 0.92, thank you very much. 0.92, thank you, and thank you very much. So remember part one, they wanted us to give them the coefficient of correlation and interpret your results. So you can see, ladies and gentlemen, that this is a 91.6% bond. 91.6% bond is way too high. So it means that the two variables are strongly related, very strongly related. The two variables are very strongly related. I mean, a relationship up to 92%. It's not a joke. So if they are strongly related, then what I'm advising, ladies and gentlemen, these people is that years of experience have a direct relationship with sales. Years of experience have a direct relationship with sales. So when you are hiring, don't hire newbies. Hire individuals who are highly experienced. I hope that makes sense. I hope that makes sense. Any question, my great students? Will you kindly ask a question? Any question, any question? Any question? And of course, out of these, I should be able to show you how to calculate what we call coefficient of determination. Right there, the last one under this, coefficient of determination. How do we get coefficient of determination? How do we get out of this R you have computed? How do we get coefficient? How do we get coefficient of determination? How do we get coefficient of determination? R squared. R squared. From the formula there, our R squared will be equal to coefficient of correlation, and then you do what? You square it. Like in this particular case, what we need to do is to come on top of 0.916, you square. So you'll come on top of, ladies and gentlemen, 0.916 squared, which will end up giving us 0.84. 0.84. 0.84. So this gives us 0.84, which is the same as 84%. 84% is what we call the explained variance. 84% is what we call the explained what? Variance. 84% is what we call the explained variance. Is what we call the explained variance. Is what we call the explained variance. Meaning that the equation that we have over here can explain up to 84% of the response variable of y. Now there are other factors other than experience. There are other factors which affect sales. The other factors account for what percentage to make it 100%? 16%. So 84% of the variations of sales are accounted for by X, are accounted for by the experience. Otherwise, ladies and gentlemen, we have here a whole 16%, which is being accounted for by other what here? Other factors. By other factors. Other factors. Any question?
Question from Edward.
From Edward, yes.
Is there no crime if you do not fill in the columns X, Y, X, and Y?
Is there any crime if you don't fill those particular cells here? No crime whatsoever. No crime whatsoever. Our examiner allows us to do that. The only thing that he has not allowed us up to date is to get the values of R, A, and B directly. And it's something that we are really wishing he could allow, because you know, all these mechanics, I mean, nowadays they're being done by computers. At our level, just like other examining bodies like ACCA, would want to be doing more of interpretations than the mechanical work of getting these schemas, etc., etc., even cracking the formula. No. Our work should be, you are given R, you are given A, you are given B, and then you're told to interpret. That should be the work that an accountant should do. Thank you very much, Edward, for asking that question. Is there any other student who has a question? Is there any student, any other student who has a question? So I would want to give you some homework. And this homework, please let it be done. It's an important homework. I would want you tonight, you try November 2018, question 3. November 2018, question number 3. And please don't leave the theory parts. Always the theory parts, fill them up. QA theories always comes with about 25% of the marks. So you can easily pass this paper by knowing too much of theory. Yes, 25%. Now, if you allow me, I will go straight away to number 2 of these. We say the correlation, we have got 2 models. We have the Karl Pearsons, and then number 2, we have the Spearmans. The Spearmans, at times in this case, here called the ranks model. The ranks model. The ranks model. So I want to see whether there is any student amongst us here who is able to remember the formula of R using the ranks model. R will be equal to what using the ranks model? R will be equal to what using the ranks model. I'm here waiting. Eyes, ears. Please check, my brother. No one has written anything. So then our R will be 1 minus 6 summations of d squared all over n cubed minus n. And then remember that this one is independent. One is independent. So we have this d representing differences between ranks. Differences between ranks. Differences between ranks. And then the most important thing that you're supposed to know, ladies and gentlemen, regarding Spearman's model is that Spearman's model is normally used to analyze. It's normally used to analyze qualitative. It's normally used to analyze qualitative variables. It's normally used to analyze qualitative variables, those variables that are neither measurable nor what are countable. You can't measure them, you can't count them. For example, female beauty. You can't attach a numerical value to that. You can't. You can't. So anytime you want to analyze two or more qualitative variables, then you can only use ranking system. Ranking system, and I want us to do this very fast. Let us consider some beauty pageant here, where we have ladies, like there could be 4 of them, A, B, C, D. So we have here ranks, in this case here by Judge 1. Then we have here ranks by Judge 2. So we have judges, of course, they can't rank them the same way. It will be very hard. Because as they tell us, beauty in this case here depends on who is doing the assessment. Doing the assessment. So then, gentlemen, here we are. Here we are. Here we are. So we happen to be having the ranks will be given ranks by your examiner. So for example, we have Judge 1 who has taken C to be number 1, B to be number 2, A to be number 3, D to hold the tail of our cow. Right? And then Judge 2 has been given an opportunity to rank these people. So Judge 2, of course, Judge 2 will have his own way of ranking. Perhaps the one who was holding the tail, as per Judge 1, in this case, here becomes number 1 there. Different ways of looking at things. So we have, according to this judge, this is 2, this is 3, this is 4. And then now you are required, ladies and gentlemen, to give us, you are required here to give us, to calculate R. You calculate R. Calculate R. Calculate R. Because of the ranks, you can only use this ranks model. Because of the ranks, you can only use the ranks model. And for us to use the ranks model, you need to come and create a column where you capture D squared. Remember, D stands for what your differences between ranks. D stands for differences between 2 ranks. So what you'll do, like now for the first lady, who was ranked number 3 by Judge 1 and number 4 by Judge 2, so we'll have 3 minus 4. And then whatever difference I get, I will square. So 3 minus 4 gives me minus 1. Minus 1 squared will end up giving me positive 1 like that. Positive 1. So from there we go to the second lady. So I can see 2 and 3. The difference there is negative 1. Negative 1 squared again gives me what here? Gives me 1. Next we have 1 and 2. Negative 1 when I subtract. Squared, that gives me 1. Next I have 4 and 1. 4 and 1 gives me 3. 3 squared gives me what here, somebody? 9. And you can see from the equation they want me to give them the summation of D squared. So come and sum the D squared, which I'm able to see is 12. Summation of D squared, I'm able to see a figure of 12 when you add the 4 figures. So ladies and gentlemen, the next thing that I would want you now to go and give me very first is the N. I would want you to go and give me N very fast. N represents the number of objects, number of items. In this case, it will be number of ladies who are being analyzed. So number of ladies here, how many do we have? There are 4. Number of ladies here, we have 1, 2, 3, 4. Number of ladies, we have 4. So from there, come and now do your substitution. Come and do your substitution. What do we have there? Do your substitution. What do we have there? So ladies and gentlemen, what we have here will be 1 minus 6 times summation of d squared. Summation of d squared, which is what here? 12, all over n, which is 4. So we have here 4 cubed minus n again, n which happens to be 4, like that. So move slowly. First of all, deal with these multiplications and the divisions. Deal with this term here. So what I'll do, first of all, I'll get the numerator. So the numerator, what do we have here in the numerator? In the numerator, ladies and gentlemen, what we have here in the numerator, is this. So we have 1 minus 6 times 12. Good to use your calculator, always 6 times 12. This will give us 72. All over, please ensure that you're cubing. This is supposed to be cubed. So we have here 4 raised to power 3. So 4 raised to power 3. I'm able to get 64. So 64 minus 4. So this will be 1 minus 72 all over 60. So we have here 1 minus 72. We have 1 minus 72 divided by 60. 1 minus 72 divided by 60 equals, I'm able to see negative 0. What here? Negative 0.2. Negative 0.2. I'm getting there. Negative 0.2 like that. Negative 0.2. Negative 0.2. Negative 0.2. So meaning that there is some relationship between the two variables, between the ranks of the two judges, which happens to be what? A negative. Meaning that the two judges have got different tastes and preferences. The other one took one lady D to be number 4, and the other judge took that same lady to be number 1. But you see now, CASNEB does not test us that way. CASNEB, ladies and gentlemen, this is not something that you expect from CASNEB. What you expect from CASNEB, if you have ever attempted this kind of exams, are like now what we have there in May 2017. Look at May 2017. I know you guys normally work with your past papers. May 2017. If you don't have them, of course, you guys are mature enough. You know that CASNEB has all those past papers for you on their website. What you need to do is to print them, put them somewhere in your file. So we have here May 2017, question number 4, boy. May 2017, question number 4, boy. Any question? Thank you very much. The table below shows marks scored by 8 students in mathematics and English subjects. So you can see the students 1 to 8. We have the marks scored in maths. We have the marks scored in English. So they want us to give them the rank coefficient of correlation. The rank coefficient of correlation, and then we interpret our results. So what do we have there at the end of the day? Ladies and gentlemen, what I will do, I will come and arrange this information in a columnar format. So we have the student there, 1, 2, 3, 4, 5, 6, 7, 8. We have here marks scored. Marks. Maths marks. We have here English marks. English marks. So we have here 31, 36, 44, 28, 56, 76, 36, 96. We have English marks. We have 56, 46, 66, 46, 36, 26, 46, 76, like that. So I would want someone to take like a minute and try to give us our R. Try to give us our R. Give us our R. Remember, they want us to use the Spearman's rank. The question itself talks of the rank's coefficient. So our R will be 1 minus 6 summations of d squared all over n cubed minus n you can do, ladies and gentlemen, is to start subtracting these figures correspondingly. That is the biggest mistake that I normally see over 50% of the students in CASNEB committing. That will be very wrong of us. Because you can see these are not ranks. These are what they are marks. Remember, ranks normally move in some chronological order, like 1, 2, 3, like that. So whenever you have like marks like these, figures which are not following another in terms of some specific order, then straight away, ladies and gentlemen, what I need to do is to come and rank these figures myself. So like now in terms of marks, who will I give number 1? The person will give number 1 is the one with 96. After that, I can see this one here with 76 takes number 2. Then I can see 56 taking number 3. Then I can see 44 taking number 4. Then I can see 36. Now for 36, there is something funny. There are 2 of them. We have 5. We have this 5. Remember, even in the primary school, when 2 of you were tying up at number 1, when you have 2 students tying up at number 1, then there will be no position 2. In that class, position 2 will be skipped. So meaning that the next number cannot be number 6. The next number can only be number 7. And I can see number 7 is this 31. So this takes up 7. And then automatically this takes up what here? 8. Like that. Now, ladies and gentlemen, I would want us to rank these students on the basis of English. So for English, look for the one who has scored best. The one who has scored best apparently is student number 8. So give him the first position. From 76, we have the next one is 66. Give this person the second position. Give this person the third position. From there, we have 46, of which I can see there are 3 of them. So meaning that these 3 students here will be number 4, number 4, and then we have number 4 like that. So given that now we have 3 people who have tied up at number 4, then we'll not have number 5, we'll not have number 6. So the next student will be position 7. So we have 36, this becomes 7, this becomes what here? 8, like that. 7 and 8 like that. Is there anybody who did that? Is there anybody who tried, first of all, doing this ranking? Is there anybody who went ahead and subtracted marks? Please be very honest with us. Be very honest with us. Are they saying anything there?
Yes.
Okay. Okay. Thank you very much for being honest. The first thing that you need to do is to come and rank. Because the method itself is called ranks model, Spearman's model, Spearman's model. And then number 2, now we need to ask ourselves, do we have in this case here what we call the tied ranks? Do we have the tied ranks? Like if you look at maths, ladies and gentlemen, we have a tied rank. We can see there are 2 students, ladies and gentlemen, here who tied up at position number what here? There is a tie somewhere. There's a tie somewhere, position 5 and position 5. So in this case here, there is a tie, marks, a tie at position 5. Meaning that you will come and give these students who are at the tie, you break the tie by giving us what we call the average rank. You give us what we call the average rank. Give us the average rank. How do you get the average rank? You look at the position they tied up in, plus the position that was skipped because of them tying. So there are only 2 students. So then, of course, if there was to be some slight discrepancy of marks, one of them would have taken position 5, the other one would have taken position what here? 6. And then you average, you say divide by what here? You say divide by 2. I want a blue marker pen. Blue marker. So we have here 5 plus 6 divided by 2. This will give us 5.5. 5.5. So there's no any other tie in math, but I have a tie in English. So we have English, a tie, at position what here somebody? I can remember it's a tie at position 4. Position 4. And this time around here, we are quite lucky because we have many students who tied up at that particular position, position 4. So remember, whenever there is a tie, you must always give us an average rank. How do you get the average rank? Quite easy. You start from the tie position. The tie position is 4. Plus, of course, these are 3 students. If there was to be a slight discrepancy between their marks, one of them would have taken the 5th position, the other would have taken what here the 6th position. So 4 plus 5 plus 6. And then you divide this by what here somebody? You divide this by 3, because now there are 3 students. So always you start with the tied position. From there now you move on like that. So 4 plus 5 plus 6 divided by 3, this will end up giving me 5 like that. This will end up giving me 5 like that. That is the average rank. Now, ladies and gentlemen, the moment you have those average ranks, you are required to come and replace. So where you see a tie, like now in Mark's tie, we have this guy is who tied at position 5. So what we're going to do is to delete their positions. You delete their positions, you give them the average ranks. So you delete this, instead write the average rank there. You delete this other one here with 5, give him the average rank. Give them the average ranks like that. Come to English marks, also we had some tied rank of 4. So delete this 4, delete this 4, delete this 4, delete these 4, ladies and gentlemen. Instead of 4, the actual one, give us the average rank. The average rank is 5. The average, when you see 4, give them the average rank. Give them the average rank like that. Now it's after you have done that you will come and draw for us our d squared now. So come and give us our d squared. Give us our d squared, differences squared. Like the first one is 7 minus 3. Whatever I get is 4. I square it. So 4 squared gives me 16. The next one is 5.5 minus 5. So we have 5.5 minus 5. We have 5.5 minus 5 squared. Then that gives us 0.25. 0.25. The next one is 4 minus 2. 4 minus 2 gives me 2. 2 squared gives me 4. From there we have 8 minus 5, giving me 3. 3 squared gives me 9. Gives me 9. From there we have 3 minus 7. 3 minus 7 gives me minus 4. Minus 4 squared gives me 16. 16. From there we have 2 minus 8, giving me minus 6. So squared. What figure am I able to get here straight away? 36. 36. From there, ladies and gentlemen, we have 5.5 minus 5, just like the other one. It will end up giving us 0.25. Then we have 1 minus 1, that gives me 0. 0 squared gives me 0. So kindly, after I've gotten this d squared, I want the summation. I want the summation. I want the summation. So come and sum this for us. Sum this for us. What do we have? We have 16 plus 0.25 plus 4 plus 9 plus 16 plus 36 plus 0.25, giving us 81 point what here? 81.5. Thank you very much. Thank you very much. Now, ladies and gentlemen, after getting that 81.5, now you have to be very, very careful. We have one concept that we have got to go through, what we normally call the correctional factor. The correctional factor. So we have a correctional factor. We have a correctional factor. We have a correctional factor. And for us to get a correctional factor, ladies and gentlemen, whenever we have tied ranks, because of the ranks which are normally skipped, there must be some errors. So we need to know how to correct. So come and give us the maths correctional factor. The maths correctional factor. The maths correctional factor. The maths correctional factor. What do we have here? Maths correctional factor. The formula is quite, not very, very nice, but it's something you have to but just master. So the correction of factor, we normally talk of m1 cubed minus m1 divided by 12, where m stands for number of members. M stands for number of members. Number of members. So for math, we only have 2 members tying up. So for math, our m is 2. So you come on top of 2 raised to power 3 minus m, which is 2, divided by 12. This is the first correctional factor. You can call it CF1, correctional factor 1. Correctional factor 1. It's an important formula. You simply master it. You simply master it. You simply master it. Unfortunately, the moment you have done this, and then you go and repeat on your own, then you become a specialist of this area. It's a simple area. It's a simple area. It's a simple area. So the correctional factor, what do we have here? We have 2 raised to power 3 minus 2 equals divided by 12, which will give us 0.5. This will give us 0.5 like that. From there, go to correctional factor 2. Correctional factor 2. Correctional factor 2. So correctional factor 2 is for English. We have English. Remember here we had 3 members who tied up. So we want the second correctional factor using this same formula. Number of members who tried are 3. So 3 raised to power 3 minus these 3 again, minus the members who are 3. And then you divide by 12. You divide by 12. It may look a little bit funny, but it's something you will love because it's like almost guaranteed. It has to be there in your exams. So we have here 3 raised to power 3 minus 3 equals divided by 12, which will end up giving us 2. So after you've gotten that, please give us the total correctional factor, which will be correctional factor 1 plus correctional factor 2. And the reason as to why we calculate these correctional factors, ladies and gentlemen, is because of the ranks which we skipped because of the tie to reduce on the errors. So correctional factor 1, you've given me a figure of 0.5 plus 2, which will end up giving me 2.5 like that. Once I've been able to get that correctional factor, my friends, the next thing now will be for us to come right away and write the formula. So remember our formula, for getting our R should be equal to 1. I may forget about every other thing, but I can never forget that 1. So it will be equal to 1 minus 6 summation of b squared all over n cubed minus n. This all over is only touching on this term. But now, ladies and gentlemen, because of the correction of factors that we must introduce a bracket there. Here we have tied ranks. So introduce a bracket there, plus the total correction of factor like that. So then our R will be 1 minus 6 times, open bracket, summation of b squared at the Radmine, summation of b squared, I don't know what, it was 81.5. Summation of b squared is 81.5. Plus our correctional factor, the total correctional factor is 2.5, like that. All over n, number of students were 8. 8. Actually, this one I normally prefer even doing it separately, because I'll talk of 8 cubed minus 8. 8 cubed minus 8. So what do we have there? We have 8. So we have 8 raised to power 3 minus 8, which at the end of the day will give us 5 what here? 504. Which gives us 504. So come and divide this with 504. Divide that with 504. So then what do we have at the end of the day? It will be 1 minus 6 times, open brackets, 81.5 plus the correctional factor, close, divided by 504. The calculator has got body mass. Mine has a problem. What are you able to get? Because mine, I think, has a battery issue. See the problem. So it will be 6 times brackets here, 81.5 plus 2.5 close, divided by 504. which gives me 1 exactly. Then now 1 minus 1 gives me 0. So these are between the two variables is exactly 0, meaning that there is no association at all between, no correlation at all between performance in math and performance in English. You can easily, there is no relationship. You can easily get somebody who's doing poorly in English but performing very well in mathematics, 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 performing very well in mathematics. Please ask a question. I know today it has not been very, very nice. Ask a question, ask a question. So again, another homework for you, May 2014, question number 2C. May 2014, question number 2, cow. May 2014, question number 2, cow. Is there anybody who has a question? So I know that today I've stolen you are about 20 minutes. I'll know what to do in our next class, or even in between the week. I'll be able to know how I can offer a free lesson for you so you can catch up. Again, the students who confused and thought that the class was to start at 7 today. So because of that, I'll know what to do in between the week to introduce something for you for free. Otherwise, for today, allow me to rush somewhere. God bless you.